In our section 4 practice, we are going to do a lot of converting between exponential and logarithmic form and using change of base formula, and then finally solve some exponential equations just to make sure you're very comfortable with it. So for our first example, log base 16 of 256 equals 2. When I convert that to exponential form, my base stays 16, exponent 2 equals 256. For B, log base 12 of 144 equals 2. Base is 12, exponent is 2 equals 144. For C, log base 81 of 9 equals 1/2. Base of 81, exponent of 1/2 equals 9. For D, log base 6 of 136 equals -2. So base of 6, exponent of -2 equals 1/36. For E, log base 4 of 1 equals 0. So 4 to the 0 equals 1. And then lastly, log base 2 of 8 equals 3. 2 cubed equals 8. Our second set of examples is converting from logarithmic to, from exponential form to logarithmic form. So 6 to the -2 equals 1/36. Log base 6 of 1/36 equals -2. For B, 7 squared equals 49. Log base 7 of 49 equals 2. 2 to the 5th equals 32, becomes log base 2 of 32 equals 5. 4 cubed equals 64, becomes log base 4 of 64 equals 3. 5 to the -4th equals 1/625, becomes log base 5 of 1/625 equals -4. And for our last example, 8 to the 1/3 equals 2, becomes log base 8 of 2 equals 1/3. Last set of examples before we solve some equations is evaluating using change of base. So log base 6 of 216, if I'm going to use my change of base formula, becomes log 216 over log 6, which becomes 3. Log base 3 of 1/81 becomes log 1/81 over log 3, which is -4. Then we have log base 3 of 19 becomes log 19 over log 3, which to 2 decimal places is 2.68. And then our last example, log base 7 of 34 becomes log 34 over log 7, which is 1.81. So now we're going to go ahead and use those, use change of base formula and converting between logarithmic and exponential form to solve some equations. And we are going to round our answer to the nearest hundredth, which is 2 decimal places. So 7 to the x equals 73. When I convert to a logarithm, becomes log base 7 of 73 equals x. Using change of base formula, we're going to do log 73 divided by log 7, which is going to give us x equals 2.2. It's technically 2.20, but you don't have to write the 0. For B, we have -6 times 13 to the x equals -72. So the first thing I have to do is get rid of that -6 by dividing both sides by -6. So we end up with 13 to the x equals 12. Converting to a logarithm, we get log base 13 of 12 equals x. Then using change of base, we do log 12 divided by log 13. And we're going to get that x equals 0.97. For C, we have 4 to the n equals 5. So converting to a logarithm, log base 4 of 5 equals n. Using change of base, we do log 5 divided by log 4. And we're going to get that n equals 1.16. Next example, 6 times 4 to the n equals 47. So again, first step, I have to divide both sides by 6. Now 47 divided by 6 is not a nice number, so we're going to leave it as 47 over 6. So when we convert to logarithmic form, we'll have log base 4 of 47 over 6 equals n. Using our change of base formula, log 47 over 6 divided by log 4 gives us that n is 1.48. For our last two examples, we'll go ahead and convert from logarithmic to exponential form. So we have log base 3 of 2x plus 1 equals 4. So when I convert to exponential form, it becomes 3 to the 4th equals 2x plus 1. 3 to the 4th is 81. So 81 equals 2x plus 1. We're then going to subtract 1 from both sides. So we get 80 equals 2x. Divide both sides by 2, and x equals 40. Last example, log base 5 of x equals 3. So that becomes 5 cubed equals x. So then x equals 125.